In this video, we're going to talk about the periodic table in an overview, and then we'll move on throughout the rest of the chapter and discuss the reasoning behind the orientation of the elements in the periodic table. Sam Keen is a science writer. He wrote a book called The Disappearing Spoon, which talks about the properties of the elements and how they were discovered and how they illustrate the properties of the periodic table. And it's a really great book. I highly recommend it. He also wrote something called The Violinist's Thumb, I believe, about evolution and evolutionary biology. So that's a good one too, if you want to check that out. But his comment, was for each element, its geography is its destiny. So what he was saying here is that where an element is located in the periodic table kind of defines what the element is. And we'll see why that is in a minute. So Mendeleev was the first, he wasn't really the first to create a periodic table, but he was considered the father of the modern periodic table. And so he arranged elements in order of increasing mass with similar properties in the same columns. But he wasn't really the first person to do this. But he found that when he arranged the elements in order, he found a pattern. And so that's really where his genius comes from. So this video is going to, a small section of this video is going to walk through why Mendeleev's periodic table was so revolutionary at the time.
Let's look at one of the first versions of the periodic table from around 1870. Here we see elements designated by their two-letter symbols arranged in a table. Check out the entry at the third column, fifth row. There's a dash there. From that unassuming placeholder springs the raw brilliance of Mendeleev. That dash is science. By putting that dash there, Dmitri was making a bold statement. He said, and I'm paraphrasing here, "Y'all haven't discovered this element yet. In the meantime, I'm going to give it a name. It's one step away from aluminum, so we'll call it Eka aluminum. Eka being Sanskrit for one. Nobody's found Eka aluminum yet, so we don't know anything about it, right? Wrong. Based on where it's located, I can tell you all about it. First of all, an atom of Eka aluminum has an atomic weight of 68, about 68 times heavier than a hydrogen atom. When Eka aluminum is isolated, you'll see it's a solid metal at room temperature. It's shiny, it conducts heat really well, it can be flattened into a sheet, stretched into a wire, but its melting point is low, like freakishly low. Oh, and a cubic centimeter of it will weigh 6 grams. Mendeleev could predict all of these things simply from where the blank spot was and his understanding of how the elements surrounding it behaved. A few years after this prediction, a French guy named Paul-Émile Lecoq de Bois-Baudran discovered a new element in ore samples and named it gallium after Gaul, the historical name for France. Gallium is one step away from aluminum on the periodic table. It's Eka aluminum. So were Mendeleev's predictions right? Gallium's atomic weight is 69.72. A cubic centimeter of it weighs 5.9 grams. It's a solid metal at room temperature, but it melts at a paltry 30 degrees Celsius, 85 degrees Fahrenheit. It melts in your mouth and in your hand.
So the genius of Mendeleev was that he was able to predict elements based on his periodic table. And he was correct. We found out that his predicted properties and the actual properties are really close. And so because he could predict the elements and we now are able to see that the full periodic table, now that we know where they all are, that he was actually correct. And so that's why he's considered the father of the modern periodic table. So I want to talk briefly about the difference between a scientific law and a scientific theory. So a scientific law is a statement of scientific fact that's based on observation, and we use it to predict future outcomes, whereas a theory is a well-tested explanation, but it explains why certain outcomes occur. And so I just told you about Mendeleev's periodic law, but the explanation for that law is the quantum mechanical theory. And so in this chapter, we are going to explore how the quantum mechanics we learned in Chapter 7 explain the phenomena that we will observe in Chapter 8.